For this module, we'll have the rates of change. So I have already discussed this with you when we were discussing the slopes, tangents, right? So the rate of change we know is a ratio. Sorry, this one's interchange. It should be delta y over delta x, but it can be anything. It can be any ratio, which is the average rate of change over the interval delta x. So this one, I'll change this later on. So delta y over delta x, similar to the slope, basically y2 minus y1, x2 minus x1. So what's y? It's f of x. So just plug in 2. So f of x2 minus f of x1 with respect to delta x. So however, when the delta x becomes really small and it approaches 0, the ratio becomes what you call an instantaneous rate of change. So this one is an average rate of change. It's a big change, just like what I have discussed before. And then just like what I've said, the speedometer of the car at that particular instant, you can look at it when you're traveling. That is what you call the instantaneous rate of change, because at that instant, there is no delta x yet. But when you want to check, for example, the average speed, you started from kilometer 10 up to kilometer 28. So that means 28 minus 10, that is the amount, or that's the speed, that's the distance you have traveled, divided by the time it took you to travel that. That's the average speed. So let's try. For example, you're given here, the supply for a certain brand of dress is S. So number of dresses, I think, x squared, x to the 4 minus x cubed plus x squared minus x, where x is the price per dress. Find the rate of change of the supply per peso change in the price. So supply, let's just assume it's number of dresses. When the price is increased from 1 peso to 2 pesos, okay, so that means first, let's solve for the supply equation. S is equal to x to the 4 minus x cubed plus x squared minus x. Okay, you're basically asked to solve for ito. You can see here, rate of change, right? Rate of supply per peso change. But then you can see here from 1 peso to 2 pesos, there are two amounts. So since there are two amounts, I can say that your letter A, you're basically asked to solve for rate of S, change in S per change in peso. When the peso, 1 peso to 2 pesos. So it's a big change. It's a measurable change. Whereas for letter B, you're basically asked when the price is 1 peso, only at that instant. So this one is ds over dx when x is equal to 1. Okay? So in here, I can say, that's simply S2 minus S1 over X2 minus X1. What is S2? Okay, 2 pesos, that's 16 minus 8 plus 4 minus 2 at 2 pesos. At 1 peso, that's 1 minus 1 plus 1 minus 1 all over x2 minus x1, that's 2 minus 1. So on top, this one is 20 minus 10, that is 10 over 1. So the answer is 10. But then look at this, supply per peso. So I can say 10 supply per peso. That's your ds or delta s over delta x. I think that's the answer, 10. And then in here, this one is a derivative. So that's 4x cubed minus 3x squared plus 2x minus 1. So when does this happen? This happens when x equals 1. So let's plug in 1. 4 times 1, 3 times 1, 2 times 1 minus 1. So 4 plus 2 is 6 minus 4. The answer is 2. Is 2 supply per peso. The supply can be pieces. I'm not sure. Whatever is given. So I hope, yeah, the answer is 2. Okay. So this one, suppose a right circular cylinder has a constant height of 10 meters. So I already wrote there. Height is 10 meters. If V in cubic meters is the volume of the right circular cylinder and R is the radius of its base, find the rate of change of the volume with respect to R or with respect to radius. If R changes from 5 to 5.1, that's in meters, 5 to 5.4, and when R is equal to 5. Okay, so basically, for a cylinder, this is the radius, this is the height. It so happened that the height is constant at 10 meters. So what's the formula for the volume of a cylinder? The volume is pi r squared times height. And since height is constant, I can say 10 pi r squared is your volume. So the only thing that's changing is the radius according to this. So the first thing being asked is what's the rate of change of volume? Pero you can see in letter A, the change is measurable. Okay. So that means for letter A, it's basically change in volume with respect to radius when radius number 1 is 5, radius number 2 is 5.1. So I can say pi, 10 pi 5.1 squared minus 10 pi 5 squared divided by 5.1 minus 5. Or I factor out the 10 and then the pi. I'm left with 5.1 squared minus 5 squared. This is 0.1. And then the top can be factored out as 5.1 minus 5, 5.1 plus 5 over 0.1. So this one cancels out. That's 10.1 times 10. That's 101 pi. This is delta V over delta R. So this is cubic meters per meter. So some of you might ask, sir, do we need to divide the cubic meters and meter, make it meter squared? So physically, you know that when we're talking about units, it makes sense. However, the reason why I'm not canceling this out is to show that for every meter change in length or radius for this matter, there is this much cubic meters changing. Can you follow? All right. Next question is letter B. 101 the answer. Delta V, it's similar over delta R. R1 is 5, R2 is 5.4. So basically, 10 pi 5.4 squared minus 5 squared over 0.4. So 10 pi 10.4 and 0.4 over 0.4. That cancels out. The answer should be 104 pi cubic meters per meter. So you can see here that it's a measurable change, 0.4. The answer is 104 pi. Lastly, letter C, when R is equal to 5. So you're only given one measurement for radius. So that means it's just 1. So in this case, it should be a derivative. Let's get the derivative of this expression. That becomes 10 pi times 2R, right? When does this happen? At radius is equal to 5. So let's just plug in 10 pi 2 times 5. So the answer is 100 pi cubic meters per meter is the dV over dt. So the answer is 100 pi. Let's go to related rates. The reason why, guys, it's called related rates, time is an independent variable, not n. Time is an independent variable. This one should be is. Okay, so you'll notice that at the bottom, it's dt. Because in here, see, it becomes a side, area over side. The other one, it's volume over radius. Whereas in here, related rates, all of them are related by the variable time. This is an example. A spherical balloon is being filled with gas at 10 cubic meters an hour. At the instant when the surface area of the balloon is increasing at 4 meters squared per hour, what is the radius of the balloon? Okay, you're given a balloon. Let's assume this is a sphere. Okay, so let's assume this is a sphere. It says there that the volume with respect to time, you can say volume with respect to time because that's 10 cubic meters volume per hour. So since it's being filled, it's positive because it's increasing 10 cubic meters an hour. Now, what's being asked? At the instant when the surface area of the balloon is increasing, what is the radius of the balloon? Okay. So the required is the radius when ds over dt is 4 meters squared per hour. So what is S? Okay, you see there's a V, there's an S. The volume of a sphere is 4/3 pi r cubed. The surface area, so S is surface area is 4 pi r squared. So some of you might ask, sir, why do we need these formulas? The thing is, you can see their dv over dt. Where will this come from? I need a v. Here, it's a ds over dt. I need an s. So, from v is 4/3 pi r cubed, I can get the dv with respect to time in here. So, 4/3 pi is constant, 3 r squared, and then you're getting the derivative with respect to time, not with respect to r. Therefore, every time you see a variable, you will have something over dt. Okay, what's given in here? You know that this one is 10. This is 4 because the 3 can cancel out. This is pi r squared dr over dt. So far, let's leave it here for the meantime. The s is 4 pi r squared. And then when we get the derivative, ds over dt is 4 pi times 2r dr over dt. So this is given for here from the bottom, 4 meters squared an hour is equal to 4 pi times 2r dr over dt. You can basically here you can solve this. What you'll notice is we're being asked to solve for the radius, but they have a common term, dr over dt. If I isolate the dr over dt on the left, what will it be? Dr over dt, that's 10 divided by 4, that's 5/2. 5 over 2 pi r squared. In here, if I isolate dr over dt, 4 cancels out, 1 over 2 pi r. And then I equate them. I can see that 5 over 2 pi r squared is equal to 1 over 2 pi r because both of them are dr over dt. So let's crisscross. 2 pi r squared over 2 pi r. Oh, see, everything cancels out except for the r. R is 5 meters. What's the answer? The answer here at the bottom, it's 5 meters. Let's proceed to another problem. The reason why I ask you to really pay attention to this is because you'll notice there are several applications. Like in each problem, the approach is different. In here, it's a cone. Water is leaking at a rate of 2 cubic feet per minute through a hole in the vertex of an inverted conical reservoir of height 6 feet and diameter 4 feet at the top. Question, how fast is the water level changing when the reservoir is 1/8 full? And how long will it take for the tank to be empty? Okay, so you're given the answers in here. So you're given here a cone. For the cone, guys, water is leaking. Since this one is leaking, what happens to the volume? Is it increasing or decreasing, guys? If it's leaking, is the water inside increasing or decreasing? Very good, it's decreasing. So originally there's water inside the tank, right? But water is leaking. That's why the rate at which the water is leaking is 2 cubic feet per minute. So 2 cubic feet per minute. But guys, please don't forget to write negative. Why? Earlier I showed you in the example, it's being inflated, therefore it's positive. The volume is increasing. In this case, the volume is decreasing. Okay, what else is given? Height is 6 and diameter is 4 when full. The height is 6. If the diameter is 4, I can say here that in here, the radius is 2. 6 feet and 2 feet. Okay. Now, since this is a cone, I can see that there is a relationship in here. All the time, this is the radius. This is all the time the height. Any height, they share similar triangles. Remember that? So I can see here that the radius over height, the relationship between them is always 2 over 6, or radius over height is 1 over 3. For every h is equal to 3 times the radius, or it depends later on. Maybe it can be r is equal to h over 3. It depends on what we need. What's being asked? How fast is the water level changing? Okay. So water level changing, the height. What's the height now? When V is 1/8 full, the tank is 1/8 of the total volume. Okay, so what's the formula for the volume of a cone? The formula is 1/3 pi r squared h. Now, I have a question, guys. In the question, how fast is the water level changing? You're asked to solve for, di ba, height? So that means I don't need the radius, because in here, look at the formula. The formula is V, R, and H. It includes those three. And all of them are changing, unlike in the first problem I gave earlier. The height is constant. In this one, the height is not constant. Why? You're gonna say, sir, the height is always 6. Yes, the height of the cone when full. But then when water is leaking, the height at this point is not 6 anymore. So that means I don't need the R in here. What I need, the one that I need in the problem is actually a dH over dt. There's no mention of the how fast is the radius decreasing, not like that. What's being asked is how fast is the water level changing. So it's only the H. So what I'll do here is I'd look for a relationship between R and H, which is here. So for every letter R, that becomes an H over 3 squared H. So this becomes pi H cubed over 27 is the volume. Okay? So now, since I have that, that means V is pi over 27 H cubed, therefore dV over dt is equal to pi over 27, 3h squared dh over dt. So some of you might ask, yes, sir, now that we know this is dh over dt, the one that we're solving, we know this, the dv over dt, it's being asked, it's already given, that's -2. What is the height? Okay. Kasi di ba sabi, this one is when v is 1/8 the total volume. So what's the height at that total volume? What I'll do is, if v is 1/8 of the total volume, which is pi 27, di ba? The height is 6 cube. Okay? Pi 27, so 6, so 27, that's what? 2, 2, and 2. Am I correct? 3, 3, 3, that's 2, 2, 2, and then this is just pi. This is the v. But the question is, so this is the v new. So this one, what's being asked is the height, right? So to solve for height, at v new, ito, v new is basically 1/8 of v total. We're solving for the v new. Solving for the height, the formula is pi over 27 h cubed is equal to pi times, yeah, it's just pi. It's a volume, right? So we can cancel out things. So h cubed is equal to 27. H is equal to 3. So the height is 3 feet at that volume. So that means we already have the h. So dv over dt is equal to pi over 27, 3 times 3 squared dh over dt. You know the dv over dt, that's given as -2. Pi over 27, this is 27 dh over dt. So we can cancel out terms. You're left with the change in height with respect to time is -2 over pi, height ito. So that means feet per unit is minutes. So from here, what I did was I solved for, I'll put steps so you understand. This is actually my step number 1. Now, after this, I went to step number 2. But then for me, actually this one is step number 2. The reason why it's step 2 is because I had to look for a relationship between H and R, because in the question, you don't care about the radius, but you know that you cannot make radius constant because as it decreases, the radius becomes smaller, the height becomes smaller. Now, for me to be able to solve this, I need the H. How do I solve for H? It says there, volume at 1/8 of the total volume. So that means I need to solve for the new volume. Now that I have solved for the new volume, solve for the height at the new volume. This is step number 5. After that, I got back to this, step number 6, to be able to solve for the final answer. What's the final answer here? -2 over pi feet per minute. There's another question. How long will it take for the tank to be empty? Okay. So, time so that it becomes empty. So that means the total volume for it to be empty, what's the total volume? Pi h cubed over 27. So this is 8 pi cubic feet. So the time for it to empty is 8 pi divided by, you know that it's decreasing at -2 cubic feet per minute. So that means the answer is 4 pi, but then you know you don't have negative time. So because the reason why it's negative in there because it's just decreasing. But you know that 8 pi and then divided by, because this one is cubic feet, using dimensional analysis, the feet and the feet cancels out, the minute goes on top. So this is actually 4 pi minutes for you to empty the tank. So the answer is 4 pi minutes. So this is step number 7. Look, next. A kite is 40 feet high with 50 feet of cord out. If the kite moves horizontally at 5 feet per hour directly away from the boy flying it, how fast is the cord being laid out? Okay, it says there 3 cubic feet per hour. So let's draw that first. Okay, so in here, let's just say there's a kite. Okay, and then that's the cord. The cord, let's just make it blue. So in here, the height, the distance away from the person, and then this is, let's just say, the length of the cord. The kite is 40 feet high, 40 feet, with 50 feet of the cord out. If the kite moves horizontally, so that means the kite is moving horizontally, that the height is always constant at 40 feet. And then it's moving horizontally at a rate of 5 feet per hour directly away. So guys, look, when the kite is moving horizontally, that means it's a change in x with respect to time because it's horizontal movement. If it's moving up or down, it's the change in height. Now, it's moving horizontally at 5 feet per hour. So 5 feet per hour. My question to you guys is it positive or negative? As it moves horizontally, what happens to the distance away from the boy? Is it increasing or decreasing distance? Increasing. So since it's increasing, this one is positive distance. Okay? So, looking at this, okay, what's being asked? How fast is the cord being laid out? So the cord is letter L for me. Yeah, let's just use S because it's S there. S, for example. So you're asked, how fast is the cord being laid out? ds over dt. At what instant? When 50 feet of the cord is out. When S is 50 feet. Kasi 50 feet is not constant if it's moving. But you know it's moving horizontally, so H is constant. So you know that this one will form a right triangle. So what happens is, let's use the Pythagorean relationship. X squared plus H squared is equal to S squared. With this, 2x dx over dt. This one, the H squared is actually constant, 40 squared. Since it's constant, that is 0. 2s ds over dt. Right? So, I'll ask you, this one is known. This one is the one that's being asked. The S is known. That's at S is equal to 50. The problem is X is not known. So what we can do here is, when S is equal to 50 feet, let's go back to the Pythagorean relationships. X squared plus 40 squared is equal to S squared. 50 squared minus 40 squared. You'd be able to answer X squared is what? X is the square root of 50 squared minus 40 squared. Therefore, X is actually 30 feet. Therefore, X now is already known. This one is your X. Let's just plug in 2 times 30. The dx over dt is given to be 5. 2 times the s is 50, and then this is unknown, right? So let's just try solving. Let's cancel what we can cancel. So this one and this is 10. So the answer is ds over dt is 3 feet per hour. What's the final answer? There, 3 feet per hour. Okay, so now we apply the Pythagorean theorem. Let's go to another example, guys. A ladder, 13 feet long, leans against a vertical wall. If the top slides down at 3 feet per second, how fast is the angle of elevation of the ladder decreasing when the lower end is 9 feet away from the wall? Okay, let's draw this first. So there's a ladder. Leaning against a wall. So let's just say that's the wall, that's a ladder, etc. Okay, what else is given to us? It says there that, of course, this one is y, this is x, and then let's just say the ladder has a length L. The ladder is 13 feet long. It's always 13 feet. It does not change, of course. Slides down, the top slides down, so dy over dt, because it's a y movement. Now, my question, guys, is when it slides down, is the distance of y increasing or decreasing? It's decreasing. Very good. Therefore, you should put there a minus sign. Decreasing at 3 feet per second. So, 3 feet per second. Now, what's being asked? How fast is the angle of elevation of the ladder decreasing when the lower end is 9 feet from the wall? So there is an angle here, angle of elevation. So you're being asked angle of elevation with respect to time when x is how far away? 9 feet from the wall. So you're asked this one, but then you see there's an angle. So for us, it's like, how do I incorporate the angle? I cannot use the Pythagorean in here. Maybe you can, but then is that the proper formula that we need? Let's see. Now, guys, look, you're given y. You don't know what x is at the moment. Okay? But L is constant. It's always 13. Now, look, with respect to the angle, what is y? Is that opposite, hypotenuse, or adjacent? It's opposite. What about L? L is hypotenuse. Very good. So I can say that sine of theta is opposite over hypotenuse, which is y over L. It so happened that y is not constant. It's changing, but L is constant. So I input here already the things that I need. All right. So if I were to solve this, I can say the derivative of this one would then be cosine theta d theta over dt is 1 over 13 dy over dt. Tama? So cosine theta, when x is 9 feet, that's 13. This is theta. This is 9 feet. Then this is y. We don't know the y yet. But look at this. Cosine is adjacent over hypotenuse. So that means, guys, I don't really need to solve for the y because the cosine of theta is 9 over 13. I can just plug it in here. And then d theta over dt is 1 over 13. What's the dy over dt? Isn't that negative 3? So that means only one unknown. Let's just cancel what we can cancel. 3 over 9. Okay. So that means the answer is d theta over dt is negative 1 over 3 radians per second. Okay, so in the first example, we use the Pythagorean formulas because we need the sides. In this example, I needed the angle of elevation, so I used the trig formula. So typically, when you use the trig formulas, either the sine, cosine, or tangent, like I would not recommend using the cotangent, the secant, and the cosecant. Why? Because cosine is just the reciprocal of of secant. Sine is the reciprocal of cosecant, right? Okay, so this one, we're done. Now, this one's quite easy. A man on the ground is watching a jet through a telescope as it approaches at a speed of 10 kilometers a minute. At an altitude of 7 kilometers, at what rate is the angle of telescope changing with the horizontal distance of the jet from the man is 24 when the jet's directly above the person. So it so happened, guys, that the angle in here, I'm not sure if it's correct, that typically when we measure angles, it's not with the vertical. It's typically with respect to the horizontal. I'm not sure whether this is correct. But we can solve. Let's see. So let's draw. So I'll just draw this triangle because this is where the angle was placed. If it's moving horizontally, 7 km is constant. The x is not constant. X only happens at one instance. But you know that you notice that this one it's negative 10 because the distance away from the person is becoming shorter. That's why I can see here that dx over dt is negative 10 kilometer per minute. That's fast. So I can see here that you know this is the angle, and then look at the angle. With respect to the angle, guys, what is letter X? Opposite, adjacent, or hypotenuse? With respect to theta, what is X? Opposite. Y is adjacent. So opposite and adjacent, I know I can use tangent theta is opposite over adjacent. So tangent theta is X over Y. What is constant? Y is always 7. Okay. I inputted all the constants already so that later on, I won't have a difficult time. I know which ones are constants. So that means maybe here, we can already get the derivatives. The derivative of tangent is secant squared d theta over dt. The 1/7, I can move it out. dy over, now we have a problem. Sorry. Why did it become y? X. That one, okay? I hope there's no problem. So with this, guys, let's see what's being asked. This one is known. It's given as negative 10. This one is the question, but we don't know what secant. So what happens is, at the time when x is equal to what's given, when x is 24 kilometers, 24 kilometers, 24/7, you'd be able to solve, let's say z. 7, 24, 25 is one of the special triangles, right? So that means secant, what is secant? Hypotenuse over what, guys? Adjacent, right? So 25 over 7 squared d theta over dt, 1 over 7 times negative 10. Therefore, d theta over dt, so this one's negative 10, and then 25. So negative 70 over 625. Am I correct? And then let's simplify this. divided by 70 divided by 5. Ilan siya, guys? 14. What is 625 divided by 5? Is it 125? Am I correct? What's the answer? Ayun, no? Negative 14 over 125 rad per second is the answer. There. And then next, when the jet is directly above the man. So, when the jet is directly above the man, what's being asked? When x is 0. So when x is 0, what's that? So mangyari, ito lang siya, 7 kilometers. Right? So when x is 0, that's the 7 kilometers is actually your z as well. Kasi di ba, x squared plus y squared is equal to z squared. When x is 0, the y squared is actually the z squared. Kasi what happens, guys, is this, you understand that y is equal to z is equal to 7. Therefore, when you plug in secant squared d theta over dt, that's negative 1 over, that's 1/7 negative 10. It so happened that the secant squared is equal to 1. Why? Because secant squared is hypotenuse over adjacent. It so happened that's the 7 over 7. So the answer is negative 10 over 7 rad per second.